question, first you look at the three trajectory equations given at the beginning. The first one is the standard form. The next is a trigonometric substitution. The third one is a simplified form of the trajectory equation, useful when the range of the projectile is known. In this question, we can find the range by the symmetry of the location of the walls. When both walls are of equal height, they will be at equal distance, one from the starting point and the other from the ending point. So using that, we are getting the range value. Once the range is known, we substitute the x and y coordinates. We have 2 points, P and Q, whose x and y coordinates are known to us, out of which P is selected because we substitute the xy coordinates of P, because that is easier. You can verify after you get the answer for tan theta by substituting for Q also, you will get the same answer. So once the tan theta value is known, we are substituting, you can use the tan theta to know the angle. Tan theta is the requirement. Now, angle of projection. Then using that angle of projection, we can also calculate the, as an exercise, you can work out the projection velocity of this problem. That you can use the range equation. That is as an extra exercise you can try. But as far as the angle of projection is concerned, substitution for x and y in that trajectory is enough. Okay. And also velocity of projection, if you work out, you should get this answer. Just to verify, I am giving you the answer for the velocity of projection, which is 45.4 meter per second. Okay. You can, well, if you can just check your answer in that case. Thank you.